Okay, so in this lesson, we're going to talk about symmetry with respect to the x-axis, the y-axis, and the origin. And we're going to look at graphs and determine if they're symmetric about the x-axis, y-axis, or the origin. But in particular, we're going to be more interested in showing symmetry algebraically. So the goal here will be to algebraically prove symmetry. Symmetry with respect to one of these. Okay? All right, so that will be the goal. All right, so let's look at some examples first of all. So if you look at this graph right here, in fact, both of these, let's say both of these right here. All right, so notice that the right side of this graph, if I were to fold it about the y-axis, I would get the left side. So you got to visually see that if I fold this part of the graph about the y-axis, I will get symmetry. I will get the other part of the graph. So in particular, you see how this is 1 unit, 2, and so on. So if I look at this point right here, let's say this point here, all right, and the coordinates of this point is 1, 1. And if I look at this point here, that's in the second quadrant, the coordinates of that point is -1, 1. And let's look at this one. So if you look at this one right here, the coordinates of that point is 2, 4. And if I look at that point here, the coordinates of that point is -2, 4. All right, so now remember, this is the graph of y equals x squared. So this is a quadratic function, so it's a parabola. Now what you want to notice is this, and that's going to be important. Notice that in both cases, see how this point is symmetric about the y-axis? So this distance here is the same as that distance. That distance here, whatever that point is, that distance right here is the same as that distance. So all these points are symmetric about the y-axis. So all these points here, these are the same graphs. All these points here are symmetric about the y-axis. This distance is the same as that distance. That distance is the same as that distance, and so on. So all these points right here, this point is symmetric about the y-axis, and so on. So this part of the graph is symmetric about the y-axis. You'll get this part of the graph back if you were to fold it. But in particular, I want you to notice this, that when when y is 1, see how y is 1? What'd you notice about the x coordinates? Same thing here, when y is 4, when the y coordinate is 4, what do you notice about the x coordinates? All right, you're supposed to notice that the x coordinates are opposites of each other. So when x is 2 and x is -2, my y coordinates are the same. When x is 1 and x is -1, so when the x coordinates are opposites, the y coordinates are the same. All right, so when we have a graph that's symmetric about the y-axis, whatever this x coordinate is, so let's say this x coordinate, I'm making this up. Remember, this is x equal y squared. So let's say this x coordinate is 5. So let's say this point is 525. Then what other point, if that's the point 525, the x coordinate is 5 and the y coordinate is 25. It's not, because it's going to be way up here. I made this up. Then what should be this point right here? So this point should be -5, 25. All right, so it's not really that, because 5 is over here, so it'll be way out there. All right, so in particular, I need you to notice this, that for y-axis symmetry, if the point xy is on the graph, then the point -xy is on the graph. So if you have y-axis symmetry, if x for xy on the graph, then -xy ought to be on the graph. All right, so watch what I'm saying. For y-axis symmetry, if the point -6, 8 is on the graph, then what other point is on the graph? All right, so remember the The y coordinates stay the same. The y's are the same. The only difference is that the x's are opposite of each other. So if the point negative 6, 8 is on the graph, and this graph is symmetric about the y-axis, then 6, 8 is also on the graph. Okay. So let's see, what else can we discuss here? So notice that this right here. So the question I need to ask you is this graph symmetric about the y-axis? All right, is this graph symmetric about the y-axis? So if you look at at how it's symmetric, see this right here, this right here. So this line here, this red line. So if I take this part of the graph that's on the right side of this red line and fold it about the red line, then they would be then they would overlap. So the question is this graph right here, this graph, symmetric about the y-axis? The answer is no. It's symmetric about this axis of symmetry, and this axis of symmetry is x equal 1. All right, so this graph is not symmetric about the y-axis. Not symmetric about the y-axis. Okay. Now going back over here, notice that for a, now remember these are parabolas, so these are quadratic functions. So remember this right here, the low point is called the vertex. So the vertex lies on the y-axis for a quadratic function. If the vertex lies on the y-axis, then you'll be able to take this part of the graph and fold it about the y-axis, and you'll get this part here. So whenever the vertex is symmetric, whenever the vertex is on the y-axis, no matter where it is, then it will be symmetric about the y-axis. So this is symmetric about the y-axis. So going back over here, you see this vertex right here? Is it on the y-axis? No. So notice this quadratic function. The vertex is not on the y-axis. It's on this axis right here, the axis, and this is called the axis of symmetry. You're going to learn about this in another section. The axis of symmetry. So this is not symmetric about the y-axis. All right, let's get this one. Is this graph symmetric about the y-axis? So in other words, if you look at this point here, whatever that point is, x, y, and you look at this distance right here, that distance here, is that the point negative xy? What about this point here, xy? And look at this distance here. Is that the point negative xy? And so on. What about this point here? If you look at this point here, look at this distance from the y-axis. Now remember that when I talk about the distance, I'm talking about the distance that point is from the y-axis. Notice you get this point here. And the answer is yes. So if you even look at this right here, if you look at this part of the graph that's on the right side of the y-axis, and I fold it, and you got to visualize this. See, when you fold this part here, you get that part. When you fold this part here, you get this part. When you fold that part along the y-axis, you get that part. Okay? All right. So in general, what I want you to notice is this. If this is the point right here, I'm making this up. See, there are no coordinates here. Actually, there is. There's some points here, you just can't see it. But let's say this is the point. I'm making this up. 1, 2, 3, 4, 5, 6, 7. That's the point 7. 1, 2, 3, 4. 7, 4. Then the question is, when I look at this distance here, go across right here, the question is this the point negative 7, 4? The answer is yes. If this point here, again, I'm making this up, let's just call it x, y. And I go along this distance all the way to the y-axis, and then go across like this. Is that the point xy? Whatever that point is. I'm sorry, negative xy, excuse me. Whatever that point is, the answer is yes. So notice that this graph here is symmetric about the y-axis. All right, now again, keep in mind about this. With regards to the y-axis, with regards to symmetry about the y-axis, if 8, negative 2 is on the graph. If it's symmetric about the y-axis, then you got to tell me what other point is on the graph. All right, and so you're supposed to remember that the y-coordinate stays the same. Notice all these y-coordinates stayed the same. What was different was that the x-coordinates were opposite of each other. So look at the x-coordinate. So the opposite of 8 is negative 8. So negative 8, negative 2 should be on the graph as well. Okay? All right, so that's symmetry with respect to the y-axis. Know how it looks. It looks symmetrical about the y-axis. If you take this part of the graph, fold it, you get that part here. Okay? Same thing here. Take this part of the graph, fold it about the y-axis, you'll get that part. Same thing here. Take this part of the graph, fold it about the y-axis, you'll get that part. All right? Okay, now let's talk about the x-axis. Okay, so let's look at this one here. Let's suppose I'm going to use this point here. Let's see, you really can't tell what these numbers are. Let's say this is the point. Okay, that's a 1 right here. All right, so let's say this is a point 2, 1 right here. 2, 1. And remember, talking about symmetry about the x-axis, not the y-axis, the x-axis. So here's your x-axis right here. So you can look at the x-axis. So remember we talked about symmetry with respect to the y-axis, and I talked about folding it about the y-axis. Same thing here. If I take this part of the graph that's above the x-axis this time, we're talking about the x-axis. Take this part of the graph that's above the x-axis and fold it about the x-axis, I should get this part here. You see it? All right, so notice these points here, though. I want you to see something. If this is a point 2, 1, and this is a point 2, negative 1. All right, this right here, that's the point. Let's see, 4, 2, 3, 4. That's the point 5. 2 right here. That's 4, and then that's 5. 5, 2. And then this right here is the point 5, negative 2. All right, so I want you to notice something. Just like when we talked about symmetry with respect to the y-axis, if the point 2, 4 is on the graph, then when I reflected about the y-axis, the point negative 2, 4 has to be on the graph. So the y-coordinates stay the same. The x-coordinates are opposites. Notice the difference with these. Notice the difference. The x-coordinates are the same now, but the y-coordinates are opposites. The x-coordinates are the same, the y-coordinates are opposites. It kind of makes sense because you're reflecting it about the y-axis. So notice when I reflected about the y-axis, I'm looking at these distances here. The distances from the x-axis are the same. So notice the x-coordinates stay the same. It's the y's that are opposites. So you're reflecting these points. Notice the x-coordinates stay the same. The y-coordinates become opposites. Same thing here. So if I look at this point here, x comma y, and then reflect it about the x-axis, notice the distances from the x-axis to the x-axis are the same. And this point here has to be x comma negative y. All right. So right here, this right here is the point. I'm making this up. If that's the point, notice this is symmetric about the x-axis. So if I take this piece here, reflect it about the x-axis, I'll get this piece here. I think about folding it. So if the point, let's say this is a point 6 comma 3, I'm making this up. Then this point here has to be what? What does this point have to be? Well, this point has to be 6 comma negative 3. So notice every point that's on this part of the graph, if I reflect it about the x-axis, then its reflection is going to be on this part of the graph. All right. Notice that the x-coordinates stay the same, the y-coordinates are opposites. So that's symmetry about the x-axis. And then look at this one right here. So let's say that each grid represents 1 unit. So this is the point, let's say 2, 1, 2, 3, 4. So if that's the point 2, 4, then what other point? Notice it is symmetric about the x-axis. If I take this piece here, reflected about the x-axis, I'll get this piece here. So notice if this is the point 2,4 in the graph, then what other point has to be on the graph? Well, the other point has to be 2, -4. Take the opposite of the y coordinates. 2, -4. And that's what this is right here. 2, -4. Okay? Alright, so that's symmetry about the x-axis. Alright, now the origin. Notice the origin. Alright, so this graph is symmetric about the origin. What we mean that about the fact that it's symmetric about the origin is this. If I take this point here, right here, okay, and go through the origin, straight distance through the origin. Remember when we talked about symmetry with respect to the y-axis, I talked about distances. So this distance here has to be the same as that distance here. This distance here has to be the same as that distance here. With respect to the x-axis, this distance here, whatever that distance is, it has to be the same as that distance here. This distance here has to be the same as that distance here, and so on. This distance here has to be the same as that distance here. This distance here has to be the same as that distance here. So we're talking about the origin here. The origin is where the two axes meet, where they intersect. So this distance here has to be the same as that distance. That distance here, notice I'm drawing this. That distance here has to be the same. Keep going across that same number of distance, the same number of units, has to be the same as that distance. Okay? So no matter where you are, keep going across. This distance has to be the same as that distance. All right, now so you need to recognize, yes, this graph is symmetric about the origin. All right, now one way to do that is to first of all reflect this about the y-axis and then reflect it about the x-axis. So reflect about the y-axis. So when you reflect this about the y-axis, you'll get, let me go ahead and draw it here. When you reflect this right here, when you reflect this about the y-axis, this piece right here, you'll get this piece here. Okay? And then once you get that piece, you reflect that about the x-axis, and then you'll get this piece here. And notice that this portion here is my graph. All right, so with regards to the origin is kind of like two transformations. You first reflect about the y-axis, then reflect about the x-axis. All right, now I want you to notice something. This point here is 1, 1. That point here. When I take this distance here and go the same distance from here to here, I get this point here. I want you to notice the coordinates of that point. The coordinates of that point is -1, -1. Same thing here. I'm making this up. Let's say this is a point. Well, let's do this one right here. This point here is 1.5, 1. 1.51. 1.5, 1. So going through the origin, I get going through the origin right here. This distance, and then just go to this distance. So that point here is -1.5, -1. So the point being, what do you notice about the x-coordinates and the y-coordinates? So notice the x-coordinates are opposites and the y-coordinates are opposites. Over here and here, the x-coordinates are opposites, the y-coordinates are opposites. Kind of makes sense because when you reflect about the y-axis, first of all, when you reflect about the y-axis, what changed? Which ones were opposites? Well, when you reflect about the y-axis, the x-coordinates were opposites. And then you reflect about the x-axis, what were opposites? The y-coordinates. So when you put them all together, and you talk about the origin, then both the x-coordinate and the y-coordinates are opposites. So if you look at the circle, so a circle is symmetric about the origin if its center is located at the origin. See how the center here? So if the center is located at the origin, then yes, this is going to be symmetric about the origin. You can even see it. This distance here is the same as that distance. That distance here is the same as that distance. Kind of makes sense because that's the radius. So remember, a circle, in terms of the center being the origin, is equidistant from the origin. So if this is the point, I'm making this up. So if this is a point, let's say, I'm making this up. Let's say 2.8 comma 1, 2, 3. Let's say 3. I made this up. Then what other point ought to be on the graph? Well, you're going to go from here to here. And remember, the idea of symmetry about the origin is you reflected about the x-axis, the y-axis rather, and then reflected about the x-axis. So when you reflect about the y-axis, the x-coordinates are opposites. When you reflect about the x-axis, the y-coordinates are opposites. So basically, when you talk about symmetry about the origin, the x-coordinates and the y-coordinates are both opposites. You can even see that. So this is the point negative 2.8, negative 3. So negative 2.8, comma, negative 3. Okay? Same thing here. First of all, do you recognize that this graph is symmetric about the origin? You have to see that this graph here is symmetric about the origin. So for example, take this distance here, go straight across. You may want to take a ruler. You'll get that point. And let's say this is the point, let's say I'm making this up, 3.2 comma 10. Then this point here ought to be negative 3.2 comma negative 10. Okay? So same thing here. If I take this point here, go through the origin, and then go same distance here, I'll get that point here. And notice that whatever this is, if this is 3 comma negative 10.2, I made this up, then this right here ought to be, was it? That's 2, sorry. This is 2 right here. Then this ought to be the point negative 2 comma positive 10.2. All right, so with regard to the origin, with respect to the origin, if negative 8, 4 is on the graph, then blank is also on the graph. So what do you think? Think about all we just talked about, and it is not that easy to visualize. But if negative 8, 4 is on the graph of a graph, now remember these are not functions here. This right here, that's not a function. So when we talk about symmetry with respect to the origin, some of them are functions, some of them are not. Okay. All right. So with respect to the origin, if negative 8, 4 is on the graph, then what other point has to be on the graph? So remember, we talked about symmetry about the origin. It's symmetric about the y-axis and the x-axis. Symmetric about the y-axis and the x-axis. Think of it that way. So symmetric about the y-axis and the y-axis. I'm sorry. Let me rephrase it. When we talk about symmetry with respect to the origin, okay, if I take this part of the graph here, reflect it about the y-axis, and then reflect it back again about the x-axis, I'll get this piece here. All right, now, a circle would be symmetric about both the x and the y-axis, but this is not. But I can get this piece graph here by taking this, reflecting about the, see this right here, reflecting about the y-axis, then reflecting it back about the x-axis, and then this red part is my original graph. So when I reflected about the y-axis, the x-coordinates are opposites. When I reflected about the x-axis, the y-coordinates are opposites. So with respect to the origin, all I've got to do is change these coordinates, make them opposites. So the point 8 comma negative 4 is also on the graph. All right, now, do you see that this graph here is symmetric about the origin? So if I take this point here, go through the origin, go the same distance, I'll get that point here. If I look at this point here, go through the origin, go the same distance, I'll get that point here. Okay? So So let's say this right here is the point, this one here. So let's say this is the point, let's see, -2, 4. So let's say this is -5, comma, I'm making this up, 0.8. Then what other point ought to be on the graph? So remember, you go through the origin, you can't see it very well, go through the origin, and you get that point here. So what other point ought to be on the graph? So this point here, when I reflect this about the origin, that point here ought to be what? What ought to be 5, comma, -0.8. So remember, we talked about symmetry with respect to the origin. The x-coordinates are opposites and the y-coordinates are opposites. Now this is y equals x cubed, so notice that this is also symmetric with respect to the origin. So if I look at the point 3, 9, so 3, 9's way up here. 3, 9's way up here. I should draw a little bit better. 3, 9, let's say, is here. That's 3, 9. Then what other point ought to be on the graph? So when I go through the origin, just draw a straight line going through the origin. This distance ought to be the same as that distance. Okay? Then what other point down here, what other point ought to be on this graph? Well, -3, comma, -9. So notice the x-coordinates are opposites, the y-coordinates are opposites. Okay? All right. Now, so we just talked about this, about the origin symmetry. The origin symmetry is a reflecting of each point through the origin. So meaning that if I take this point, go through the origin, see that distance here, where that distance is, go through here, there's a straight line, straight segment here. Then if this is a point, I'm making this up, 1, 2, 3, 2, then this right here has to be the point -3, -2. That's all that says. Okay, so let's talk about symmetry. All right, now this is going to be important. All right, so this is talking about y-axis. So let's think about the y-axis symmetry. Remember, when we talk about the y-axis, so always for the y-axis, think about this right here. Just think about x squared. Y equals x squared. For the y-axis, it is always easy to think about y equals x squared because y equals x squared looks like this. So it is symmetric about the y-axis. So this says here, if xy is a point on the graph, okay, then what is this point here right here? Then that's going to be the point -xy. So let's say -xy is also on the point of the graph. Okay. All right. Let's talk about the x-axis symmetry. For that one, it is always good to think of this. Think of this right here. Now, by the way, this is the graph x equal y squared. That's the graph x equal y squared. All right, so when I graph this, and they're saying this, if this is a point right here, if xy is on this graph, then, and it's symmetric about the x-axis, then this distance is the same as that distance. What is this point here? Well, they're saying that point has to be x negative y. So the y-coordinates are opposites, and that's what this says. Okay? Now the origin, for the origin, think of y equals x cubed. Think of that one. Y equals x cubed. That's x. Looks something like this. All right? So if the point xy is on the graph, and I go through the origin, remember x cubed is the origin, so the origin. This is x-axis symmetry. So y-axis symmetry, think of y equals x squared. X-axis symmetry, think of x equal y squared. Just think of this graph right here. Think of this graph, think of this graph, and then think of this graph that goes to the origin. So this distance here has to be the same as that distance, and they're asking, what is this point? Well, if that's xy, then it has to be -x, -y. And that's what that says right here. Okay? All right, now, let's look at this. This graph here, is that graph symmetric about the x-axis? Yes or no? Well, if it was symmetric about the x-axis, then this point here ought to be here, and it's not. So the answer is no. The y-axis, Is this point here symmetrical with the y-axis? If it is, then that point here ought to be here. Is it? It's not. It's got to be on this graph, I should say. All right? So no. Is it symmetrical with the origin? Well, if it is, then that means that the distance from here to here has to be the same from that distance here to here, and that point is also on the graph. And it is. So notice that this point here, whatever that point is, when you reflect about the origin, this distance to this distance, you get that point. So it is symmetrical about the origin, so that's this one. Over here is symmetrical about the x-axis. Is this point, when I reflect about the x-axis, I'll get that point. This point, reflect by the x-axis, I get this point on the graph. So on. Yes, it is. Is it symmetrical about the y-axis? No, because when I take a point here, reflected about the y-axis, this point's not on the graph. It's not on the graph. You can see it's not. So it's none of these. It's not the origin. All right, now over here, if I take this point here and reflect it about the x-axis, do I get a point of the graph? Yes. If I take this point here, reflected about the x-axis, do I get a point on the graph? Yes. So it is x-axis symmetry. Y-axis, if I reflect this point about the y-axis, do I get this point? Do I get a point on the graph? Remember, this is your graph here. If I take this point here, reflected about the y-axis, do I get this point here? Yes. The origin, if I go from here to here, and then go from here to here, do I get this point? Yes. If I go from here to here, and then the same distance, do I get that point on the graph? Yes. All right, so it's all three. So this one here was symmetrical about the the x-axis. You can see it. If I take this portion, fold it, I get that portion back. If I take this portion, fold it about the y-axis, get this portion back. And if I look at distances for the origin, take this point here, go this distance, then go this distance again, I get a point on the graph. And notice that if this is the point, I'm making this up, let's say this is 3, 4, then this point here has to be -3, -4. Okay? All right, so let's see. Let's just go to this. All right, so test for symmetry. Now, this is the algebraic test, so that's what we're about to talk about. Okay. Now, remember when we did this? When we did, let's start with y-axis here. So remember, the y-coordinates are the same. So basically, to determine if an equation represents any kind of symmetry, if it's a y-axis symmetry, I take x and replace it with -x. So this says replace x with -x in the equation. If an equivalent equation results, the graph is symmetric with respect to the y-axis. Remember, for x-axis symmetry, what were the opposites? The x-coordinates stay the same, but the y's were opposites. So now I'm going to replace y with -y. So for x-axis symmetry, replace y with -y. And if an equivalent equation results, the graph is symmetric with respect to the x-axis. And the origin, remember the origin, they were all opposites. X, -x, y, -y. This says replace x with -x, y with -y. And if an equivalent equation results, then the graph is symmetric with respect to the origin. Okay? All right, so let's look at some examples. All right, so we're going to do this algebraically. So in my math lab, that's what they're going to ask you to do. All right, so number 1, determine algebraically. So determine algebraically. Okay, here's number 1. Suppose we had this equation, y equals x squared plus 6. And the question is determine algebraically whether it's symmetric about the, let's see, symmetric about x-axis, y-axis, origin. Now, if it's not symmetric about any of these, that's the origin here, O-R-I-G-I-N. If it's not symmetric about any of these, then you say neither of these. Okay, neither of these. All right, so let's do the x-axis symmetry first. So we're testing for. Now this is what you have to do. We're testing for x-axis symmetry. right, so that's the first thing you do, test for x-axis symmetry. And here's the algebraic process. You're going to replace, remember, x-axis for the x-axis. If you can't remember this right here, it's easy to figure it out. If you can't remember this, it's easy to figure out. So in your mind you have this. This graph's symmetric about the x-axis. So if this is the point xy, then this is the point x negative y. So basically you're going to look at these, because that's the ones that are opposites. These are the same. So replace y with negative y. Replace y with negative y. Alright, so here we go. So here's my y. What do I replace it with? Negative y. So I get negative y equals x squared plus 6. And now all you do is compare this with this. And the question is, if those equations look exactly alike, then it's symmetric about the x-axis. So are these equations exactly alike? Do every term look exactly the same? The x squareds are the same, the 6's are the same, but what do you notice about the y's? Are the y's the same? No, they're opposites. So in other words, is that equation the same as this? The answer is not the same. So with regards to the x-axis, y equal x squared plus 6 is not symmetric about the x-axis. Okay? All right, number 2. I'm sorry, this is part A. Part B, test for y-axis symmetry. Test for y-axis symmetry. So for y-axis symmetry, you have this in your mind. This graph is symmetrical with respect to the y-axis. If this is the point xy, then this point here has to be negative xy. So for that, you replace x with negative x. All right. So wherever we see an x, I plug in negative x. So here we go. We go back to the original equation. Y equals x, which is which I replace with negative x. Whatever that is, I squared plus 6. Now be careful. Simplify this. Negative x squared, remember, means negative x times negative x. Well, a negative times a negative is a positive. X times x is x squared. So this right here becomes x squared plus 6. Now compare this with the original. What do you notice about this and the original? Well, you notice that those are the same. Y, x squared, 6. Y, x squared, 6. So you're going to say, so those are the same. So you're going to say, so the answer is going to be this. You're going to say y equals x squared plus 6, the original, y equals x squared plus 6, is symmetric about the y-axis. All right, C, let's test for symmetry. About the origin. So remember, the origin looks like this. You think of y equals x cubed. It looks like this. So if this is the point xy, then this here has to be the point negative x, negative y. So basically, you're going to replace x with negative x, y with negative y. All right, and then see what happens. Okay, so here's the y. Oops, sorry. So here, go back to the original. Here's your original. Y equals x squared plus 6. All right, so here's the original. So we're going to place x with negative x, y with negative y. So I get negative y equals negative x squared plus 6. Simplifying this, I get negative y equals negative x squared is x squared plus 6. All right, so remember, this equation has to be exactly the same as this. So notice, what do you notice about these two equations? They're not the same. So therefore, we have to say, so the answer will be the original equation was this: y equals x squared plus 6. So we have to say this. We have to say y equals x squared plus 6 is not symmetric about the origin. So there's only one symmetry here. Y equals x squared plus 6 is symmetric only about which one of these? Well, it's symmetric only about the y-axis. Right. And then if you graph it, I'm just showing you what the graph looks like. And you graphed this last semester, y equals x squared plus 6. So basically y equals x squared plus 6, the origin, the vertex is going to be here. This is a graph, y equals x squared plus 6. And notice it is symmetric about the y-axis. All right. But remember, if it says algebraically, this is what you got to do. You can't use a graph. If it says algebraically, you cannot use a graph to determine symmetry. It is very easy here. If you know what the graph looks like, you can tell it's symmetric about the y-axis only. There's no x-axis symmetry, and there's no origin symmetry. It's only the y-axis symmetry. But if it says algebraically, you have to do this. Notice the work you have to do. You have to replace y with negative y. You have to replace x with negative x. And then for origin, you have to replace both of those. All right, let's look at another one. Okay, this will be number 2. Okay, number 2, it's a lot of work, so notice what you have to do. All right, number 2, let's say we had this one. Let's say we had x equal y squared plus 6. X equal y squared plus 6. So let's do the, again, you want to look at the symmetry. So we're going to check for x-axis symmetry. So remember, x-axis symmetry, think of this. So this is the point on the graph, and I go about the x-axis, then that point here needs to be on the graph as well. So it's going to be x comma negative y. So I replace y with negative y. So replace y with negative y. All right. So here's my original. So I'm going to rewrite my original, and then we replace y with negative y. So I get x equal negative y squared plus 6. Simplifying this, because we all know that negative y times itself is y squared. Okay, now compare this with the original. What do you notice about those two? This and this. You notice they're the same. All right, so you're going to say the answer. You're going to say x equal y squared plus 6 is symmetric about the x-axis. All right, now let's do part B. So part B, you want to check for y-axis symmetry. So if the point xy is on the graph, and I go about the x-axis, then this point here needs to be on the graph as well. So that's going to be the point negative xy. So for y-axis symmetry, I replace x with negative x, because the y's stay the same. All right, so we rewrite the original. So my original is this, x equal y squared plus 6. And so I'm going to take x and replace with negative x. So I get negative x equals, everything else stays the same. Now look at this. I can't do anything with negative x. Negative x stays negative x. Now look at these. Are those exactly the same thing? The answer is no, because these are not the same thing. So not the same. So we say that, so the answer, you'll say this. X equal y squared plus 6 is not symmetric about the y-axis. Okay? Okay, what about the origin? Origin symmetry. So that's the one where you replace both of them. So replace, so in other words, if this is the point xy, and I go about the origin, then this point here has to be on the graph as well, negative x, negative y. So replace x with negative x, y with negative y. So replace x with negative x, y with negative y. All right, so we rewrite the equation over. So x equal y squared plus 6, and again replace both x and y. So negative x equal negative y. So y becomes negative y squared plus 6. The only one I can simplify is this one right here. So negative x equal y squared plus 6, and I compare these two. Are those two exactly the same? The answer is no, not the same. Not the same equation. So the answer here would be not symmetric. Well, x equal y squared plus 6 is not symmetric about the origin. Right. Now, if you were to graph this, using a t-table, and we're saying x equal y squared plus 6, and if you were to take the time and do the t-table, you would actually get this. 1, 2, 3, 4, 5, 6. It would look like this. All right, that will be the graph. This is the graph of x equal y squared plus 6. And that's a 6 here. So if you just do a t-table, you'll see that's what you'll get. Now, that's not a function. All right, so that's why nowhere in here did I say this function is symmetric. All right, I just said this equation is symmetric. But notice that the only symmetry you see is x-axis symmetry. You don't see y-axis symmetry, and you don't see origin symmetry. It's just x-axis symmetry that you see. All right, let's do another one. Okay, let's suppose we had this one. All right, number 3. All right, let's suppose you had y equal x squared plus 6. Well, I'm sorry, y squared equal x squared plus 6. Y equals x squared plus 6. So when I look at x-axis symmetry, all right, and I replace I replace y with negative y. Remember x-axis, to do that, just think of this. X, y, you're symmetrical at the x-axis. This point has to be in the graph as well. That's going to be x negative y. So replace y with negative y, y with negative y. All right, so I'm just going to write my equation again. Y squared equal x squared plus 6. And wherever I see y, I replace with negative y. So I get, here's the only y I see. That's an x. So I get negative y squared equals x squared plus 6. Negative y squared, you need to know that that's just y squared equal x squared plus 6. And I'll compare the two. Notice that this equation and this equation are the same. So the answer, y squared equals x squared plus 6, is symmetric about the x-axis. All right, B, let's talk about the y-axis symmetry. All right, so we'll replace y with, replace x with negative x. So again, think about what you're doing. So y symmetry, if the point x, y is on the graph, always think of this. If the point x, y is on the graph and reflected about the y-axis, I get this point here. That needs to be on the graph as well, and that's going to be the point negative x, y. So the y stay the same. The only thing that changed with the x's. So x becomes negative x. So replace x with negative x. All right, always do that in your mind. So my original was this. So y squared equal x squared plus 6. And I'm going to replace x with negative x. So y squared equal negative x squared plus 6. Negative x squared means x squared. Negative x times negative x. So that's x squared plus 6. And now compare the two. What you notice, well, these two are the same. So this equation, so the answer, y squared equal x squared plus 6 is symmetric about the y-axis. Okay. All right. C, origin symmetry. So we're going to replace both of them. So replace x with negative x, comma, y with negative y. replace x with negative x, y with negative y. Okay, go back to your original equation. My equation was y equals x squared plus 6. Now let's replace. Y becomes negative y, x becomes negative x. So in parentheses, we put negative y squared equal negative x squared. Make sure you put that in parentheses, plus 6. And then negative y times negative y is y squared. Negative x times negative x is x squared. And then plus 6. Now compare the two. They're the same. So your answer here will be, notice that this equation is also symmetric about the origin. So y squared equal x squared plus 6 is symmetric about the origin. So in this case, so symmetric about the origin. So in this case, this equation is symmetric about all three. So notice that y squared equal x squared plus 6 has symmetry about x-axis, y-axis, and origin. Okay, so x-axis, y-axis, and origin. Okay, let's see. All right, so we're almost at about 51 minutes now, but that's all you do to check for symmetry. Okay, and well, let's do this one. Suppose we had this. Suppose we had all right, let's suppose we had y squared equals x squared plus x. Let's say we had this. Okay, y squared equals x squared plus x. So let's check for x-axis symmetry. So we're going to replace y with negative y. So when I replace y with negative y, I get, well, here's the equation though. So I get y squared equal x squared plus x. So now I'm going to replace y with negative y. So I get, that's an x here. So I get negative y squared equal x squared plus x. Negative y times negative y is y squared equal x squared plus x. And now compare the two. Notice they're the same. So y squared equal x squared plus x is symmetric about the x-axis. Okay, B, let's do y-axis symmetry. So we're going to replace x with negative x this time. So remember, always think of this. If this is the point x, y, then this point here, remember we're talking about y-axis now, so reflect about the y-axis, then the point negative x, y has to be on the graph. So replace x with negative x. So the equation was this. So I get y squared equal negative x squared plus a negative x. So all I did was wherever I saw an x, I replaced it with negative x. Now let's simplify this. This part I can simplify. You know that a negative x times a negative x is x squared. And then that's just minus x right here. All right, now compare that with this. Are those the same equation? Is every term the same? Does this equation look exactly like this? The answer is no, because of that x, this is negative x. So not the same. So y squared equal x squared plus x is not symmetric, about the y-axis. And then C, let's talk about the origin. So in this case, I would have to replace both x with negative x and y with negative y. All right, now notice what happens when I do that. Replace x with negative x, y with negative y. All right, and so I'm going to get Okay, the original equation was this right here, y squared equal x squared plus x. And so negative y squared equals negative x squared plus a negative x. Negative y squared means y squared. Negative x squared means x squared. And then that becomes minus x. I can compare these two. You notice that they're not the same. So that means that y squared equal x squared plus x is not symmetric about the origin. Okay? So it only has one symmetry. The only symmetry it has is the x-axis symmetry. That's all it has. All right, now what about if you had this real quickly? I know I'm running out of time. This is almost an hour. What if we had this? Y equals, and see how I had this right here? Y equals x squared plus x. I mean, y squared equals x squared plus x. What if I just had this? What if I had y equals x squared plus x? All right, now let's look at this one. So A, x-axis symmetry. Now remember, if it says do this algebraically, which it does, this is the work you do. Notice the work. So that's what you have to show on a worksheet if you have to do these on worksheets. Do not use a graph. Now, graphing here, because you hadn't learned at this point how to graph something like this, but you will soon, and you don't have access to a graphing calculator, so you can't use a graph on this. All right, so x-axis symmetry, you're going to have to do this algebraically. So we're going to replace y with negative y. So I get, so I'm going to rewrite it over. So I get y equals x squared plus x. So replace y with negative y. So negative y equals x squared plus x. That's all I do. I compare these two. Do they look exactly the same? The answer is no, because of this. Those are not the same. So you have to say this. You have to say answer. You have to say y equals x squared plus x is not symmetric about the x-axis. Okay, B, let's do y-axis symmetry. All right, now remember, if you get a little confused as to what to replace, always draw a point like this. Always put the point in your first quadrant. Now, if you're symmetric about the y-axis, you get this point here. When you reflect it, this point here should also be on the graph, and that's going to be the point. See, these distances are the same, so that's going to be the point negative x, y. So the only thing you have to change is x becomes negative x. The y stay the same. So replace x with negative x. So I'm going to go ahead and rewrite the equation. My equation was this: y equals x squared plus x. So I'm going to replace x, wherever see an x, and replace it with negative x. So y equals negative x squared plus a negative x. And then simplifying this part here, there's the only one I can simplify. Y equals x squared, and that becomes minus x. So I can compare these two. Notice that this equation are the same because of this. This is a positive x, this is a negative x, so not the same. So the answer, you would say y equals x squared plus x is not symmetric about the y-axis. And then finally the origin. The origin. So remember, this one you replace with both. So think of this. If this is the point xy, and I go about the origin, same distance, then that's going to be the point negative x, negative y. So if the point xy is on the graph, then this point needs to be on the graph as well. So x becomes negative x, y becomes negative y. So I'm going to replace x with negative x, y with negative y. So remember, your equation was this. Always rewrite the equation. And wherever we see a y, you plug in negative y. Wherever we see an x, you plug in negative x. So we get negative y equal negative x squared plus a negative x. Simplifying, the only thing I can rewrite differently is this one. So negative y equals x squared, because negative x times itself is x squared minus x. So when you compare the two, notice they're not the same. So the answer would be y equals x, that's a y. Y equals x squared plus x is not symmetric about the origin. So basically what you found this. You found that y equals x squared plus x is not symmetric. Not symmetric about the x-axis, y-axis, or origin. All right, now be a little bit careful. All we're doing is testing about the x-axis, y-axis, and origin. Remember, when I go back to this other one, and that's what I need to get you to recall, when I go back to this one here, see this right here? This graph, remember we said, was not symmetric about the y-axis, but it did have symmetry. It did have symmetry. The symmetry was this line right here. X equal 1 was the axis symmetry. All right, and that was a quadratic function. This was a quadratic function. This was y equals, you can't see it, but that was y equals x squared minus 2x minus 3. That's what the graph looks like. You're going to graph something like this soon. So what I want you to notice is whenever we say that it's not symmetric about those three, that doesn't mean it doesn't have symmetry. All right, it could still have symmetry. It could still have symmetry. These equations could still have symmetry. We're just testing about these three common ones: x-axis, y-axis, origin. In fact, this right here is a quadratic function. It's going to have symmetry. All quadratic functions have symmetry, and it's going to be that axis of symmetry. It's just not one of these. Okay? All right, so just keep in mind that when we say it doesn't have symmetry about these three, it could still have symmetry about something else. We're only looking at these three for right now. Okay. All right, so that's the end of this lesson. It was a pretty long lesson. It's not an easy one. It is a difficult lesson for students to understand. But do the best you can with the algebraic approach for determining symmetry about the x-axis, y-axis, and origin.